Introducing aPriori.
The next one coming up is a really fun skit that we put together. As you can see here, we've got different podiums representing the different roles that people play throughout the product development life cycle. And so the next presentation is called The Power of Teamwork. And you heard Stephanie a little bit earlier talk about this new product, aPriori Workspace. And so it's going to be one of the underlying technologies that's going to fold all these people together, allow them to communicate efficiently, assign tasks. You're also going to see aPriori's sustainability products as they're starting to come out. We're about to release those in the next few months. And so you're really going to see how the entire team can work together to reduce product costs, assess manufacturability, and develop sustainable products. So we're really going to put everything together here. And so what I'd like to do is I'd like to introduce our team. These are all folks from the aPriori product management and product marketing team. So first we've got Chris Jesnak. Come on up, Chris. We've got Cormac Eastwood, Barton Finney, and Gibson Peters. So come on up to the stage, folks. And Mark Rushton. Can't forget about him. All right, guys. So enjoy this presentation. Should be a fun one.
All right. Thanks, Rick. Well, welcome, everyone. If those here, you'll see me driving around this electric remote-controlled car and truck. I just want to ask a question in the audience. How many people have driven a remote-controlled truck or car before, if you raise your hand? All right, keep those hands up. How many of you still own one? There's no shame in this. All right, great. Well, in a moment, I swear this will make sense why I'm driving this around in here. But first off, welcome, and thank you for joining us here in Boston. Today, first off, too, just want to give a round of applause for Tristan and the team at Carrier for everything they've accomplished. It's a really remarkable story. So I'm Chris Jesnak, as Rick introduced earlier, and I lead the product marketing team here at aPriori. Today, I have the privilege to speak to you about something I'm really passionate about, the power of teamwork. I think we can all attest to this. We can all achieve a lot more together when we're all working together towards common goals. And in a moment, we're going to show you how using aPriori's Manufacturing Insights platform can do this through a demonstration. And for the first time, many of you will be seeing AP Workspace, a new cloud application for team collaboration and task management. But first, I'd like to introduce the team here who's joined me up on the stage. So Mark Rushton. Mark is joining us from London area and is our senior product marketing manager responsible for AP design. Mark has over 17 years experience in 3D printing, product design, and manufacturing. Mark, welcome. Next, we have Cormac Eastwood. Cormac is our product manager for AP Pro. Cormac is joining us from Ireland. And Cormac has nearly 10 years of experience in the manufacturing industry and has held various roles here, including expert services and others. Cormac, welcome. And Gibson Peters. Gibson's our product manager for sustainability, local to the Boston area. Gibson has over 15 years experience in clean tech, energy, and manufacturing. So Gibson, welcome again. And Barton also from local to the Boston area, senior product manager for AP Workspace and sourcing. And Barton has over 10 years, nearly 10 years experience here at aPriori. So welcome to the team here. So I want to start off, and before we get into the demonstration, we want to give some background really on why we've built out what we have and to get everyone thinking, right? So we want you to imagine your product. And many of us here really work on and design, manufacture, source very complicated products, cars, trucks, buses, aerospace systems, HVAC systems, wind energy, you name it, right? So all of us here are likely part of the teams here shown on the right. And we're all working together within your teams and departments to work on goals for your products. And you can see some here on the left-hand side. So whether that's profitability goals, whether that's going to market at a certain time, speed to market. Maybe that's performance related or quality or sustainability. Products often come with many goals, and the challenge here is how do you bring all these teams together and the stakeholders working on them as fast as possible to meet these goals. So how can teams come together, and what information do you need and tools to achieve these goals? So you want to imagine your product, right? But we also want you to imagine, and this is why I drove this truck here. In a moment, we're going to be working as a team, improving the design of this truck. And at the end of the presentation, we're actually going to be giving this away. So pay attention, there's more to come on that. All right, so when product goals, we strongly believe when product goals can be achieved faster with the right manufacturing insights. And we're going to look at 3 of them here. Now the first one is, if your product goal is related to profitability, you can really think about that as in 2 areas, right? You can look at the price of your product. We could also look at the cost of a product. And so the question that arises is, what should this product cost? And so to get to that answer requires a whole bunch of analysis and data and information to tackle that. And so when we say manufacturing insights, we call this at the very high level product cost, right? But there's a whole bunch of information needed to find that out. So more to come on that in a moment. But next one, let's say your goal is related to performance, right? And so if we take a look at this, performance could mean a lot of things. We're going to be looking at this car here in a moment and tie it back to that. But for example, some questions that might arise is how can we improve designs earlier on to reduce manufacturing issues? Maybe by doing so, it might reduce the weight of our product. Maybe there's another design element that improves performance in another area. So the manufacturing insights that teams are often looking to seek out here are related to manufacturability, or you might hear us refer to it as DFM, or design for manufacturability. And then third here is sustainability, right? We heard this through the presentations earlier today with Tristan at Carrier. There's some challenges out there in order to do this. But largely, one area that often companies start with is around product carbon footprint. What should the carbon footprint be of our product? What should it be of our own factory? What should it be for our suppliers? So you start to look at scope 1, 2, and 3, all these different emissions, and try to figure out, how do I calculate that? And so we call that the third area here of manufacturing insights, sustainability, and particularly product carbon footprint. But the fact is that you look at these enable us to achieve faster product success if we're able to get them in a quick and efficient manner. But the challenge is that these insights often remain locked. And you look at why they remain locked, we largely see 2 primary reasons. An inability to create insights efficiently and transparently. And so the other one is just not getting the information to the right teams at the right time. And so these insights, look at the middle here, remain locked because you're not either getting them to the right teams and we're not maybe generating them fast enough. So if you're not able to do that, often what could happen is product goals can be challenging to meet. Compounding this, if you look at some additional challenges that teams face unlocking these insights, first up is just ability to create useful and accurate insights is taking too long. And we looked at that, and you could think about what insights we're looking to generate. It could be on the design aspect, it could be on maybe the process itself, or maybe somewhere in the supply chain. We're trying to figure out and model maybe what would happen in this scenario. It's really challenging to do this efficiently. Next is that conversations are difficult to track and keep track of. Your communication today internally, I know you could speak to this, and we've talked to many of you and we've seen this. We spend majority of our time in email and chat. And your conversations might look a little bit like this at times, where you think about, I had that conversation with a colleague 2 weeks ago, or was it 3 weeks ago, or 4 weeks ago? Where can I go back and how do I find that information that we were collaborating on? Sometimes it could be really challenging. And it can result in redundant work and just overall lack of efficiency. And next up here is just locating and tracing data. We're creating so much data nowadays, right? Whether that's in Excel, maybe Power BI, maybe another business intelligence platform. Where do you find that? How do you go back efficiently to search for that information? Is it in a PowerPoint I saved? Is it on this Excel on someone's desktop? Where do you get that information, and how can you find it in a fast manner? So compounding these, additionally, is the fact that all of the tools often that companies are using are not connected to each other. So if you put those 3 insights we talked about in the middle here, product cost, manufacturability, or DFM, and sustainability. And you think about, we all have tools to create those insights. So that information might be saved in one area. And we also have tools to report and analyze this information, right? We might have different set of tools to collaborate on them, and it might be completely different depending on the team, the location you're in, the department, maybe the division. And then there's also task management tools and apps out there to go and manage, right? But the challenge that we often see is that when these aren't talking to each other, this can really result in siloed data, and data, again, that's not getting to the right teams at the right time. So we start to see an inability, and it's really challenging to get it to those teams shown on the periphery here, whether that's cost engineering, maybe it's within your group, maybe that's sharing it to the whole design engineering group, or to sourcing, you name it. So what we're introducing today, and some of you are already familiar, and Stephanie showed it as well earlier on this morning, is our Manufacturing Insights platform. This is a suite of applications enabling teams to develop successful products faster. When you look at our platform, this is grounded right in the middle here, around those three insight areas that we're developing and generating: cost, DFM, and sustainability or carbon footprint. And foundational to what we do, we start with digital factories. This is the data needed to model either your own factory or a factory within your supply chain, right? Next is the ability to analyze geometric intelligence and take information from 3D CAD and simulate and model a manufacturing process. We pair those two together and we put them through our simulation engine, which then tells you certain insights shown in the middle here in all different areas. And so when teams are using our platform, you largely start using one of our applications to create those insights. This could be aPro, which for experts, users, cost engineers, or AP Design for design engineers. There's also tools to analyze. In AP Analytics is for reporting and analytics. But what's new here that we're going to be showcasing in a moment is an app for team collaboration. This is AP Workspace. Not only is it for collaboration, but it's also to manage tasks. So someone in cost engineering or maybe design engineering creates a scenario, and now I can collaborate with my team and see those insights all along the way. Now, what's not shown here is AP Generate. AP Generate is a way to automate all of this. If you didn't get the chance during the demo session to go out and see AP Generate, I encourage you to do this. This is the way to integrate with PLM and what Tristan had mentioned earlier on in his presentation. So this is the first time many of you will be seeing AP Workspace. When you log into Workspace, this is what you'd be looking at, right? So this is one scenario that this user has created around a turbine assembly. And you can see that 3D model in the middle here. I want to highlight 4 things in Workspace that you'd be doing and using this for. So one is the ability to pin comments directly on the 3D model and the data. So now you can really start to contextualize the feedback that you're getting, right? Rather than putting that in a chat or an email or some other area, if you have a complicated 3D model, we've often found and gotten feedback that it's a lot more helpful to see that directly where that certain feature is. Those comments are able to be traced and tracked and searched with real-time collaboration, which you can see on the right-hand side here. So as someone's going in and making a comment, and you can see the different color-coded bubbles that are around here with people's initials, those are comments that are showing on the right. And additionally, you can manage tasks. So if you decide, I think this is an important task to follow up on, I can either assign that to myself, to my team, or maybe to another department, where now you can use Workspace and go another area where you can search on all that, which we'll show you momentarily. And then lastly here, you have the detail of the insights all along the way. No more going back and forth between different systems that aren't connected to each other. You have that each step along the way on the bottom here, and you can go through and see the detail around that cost or carbon footprint. So we've seen here with AP Workspace in our platform that unlocking manufacturing insights faster, and we're going to show you here through the demonstration, speeds up product success. We start to take those insights and unlock them. We're getting them to the right teams at the right time, and we start to break down those silos, whether it's amongst teams or amongst the tools that we're using. And what we've seen, and companies are able to do this, product goals are more likely to be met on time. So now we're going to begin the demonstration, and we're just going to introduce the scenario a little bit here. So Mark here is going to be representing a design engineer, Cormac, the cost engineer, and Gibson's going to act as our sustainability expert, and then Barton is going to be acting as our commodity or sourcing manager. And we're going to be guiding you through and really working on a new product introduction. And the scenario at hand is that we're all working together here as an RC car, truck designer and manufacturer developing our next-gen product. We've collected some market intel, and we've learned our competitor A, has moved fast to get to market with a new battery-powered car. But we've also learned some information here. It's not fast enough, and it's overpriced, right? So we're on a mission here to design our next product, and we also have a new corporate initiative that all new products must be aware and calculating carbon footprint. So that's the first step, right? To baseline and see where you are, and then figure out ways how can we go ahead and reduce that. And then we also have an onshoring initiative. We've gotten burned by the supply chain constraints that have taken place over the past year. So we also have an initiative here to reduce lead time. So when you look at our goals at hand here, price and margin, the challenge though is our cost is too high. Performance, we want to improve speed and battery life of our vehicle here, but it weighs too much. And then we also need to be aware and design a sustainable product. But carbon footprint, we need to find ways. We have no way of reducing that today. Now, we can't design this whole car today, right? That would be a challenging feat. So we're going to focus specifically on the front suspension assembly, and we're going to look at this green part highlighted here that we're going to call the scuff plate, right? This is the plate that prevents any rocks and debris from damaging the internal battery system on the vehicle. All right, so without further ado, we're going to go ahead and start to begin to improve our product, and we're going to start with Mark. Over to you.
Thanks, Chris. Hi, everyone. So we're going to start off where design engineers spend most of their day in CAD. And as Chris mentioned, we've got the front suspension assembly open. And the candidate we really think we can make some improvements is this shielding component, this scuff plate assembly. So it is actually an assembly. We've got a sheet metal piece with two mounting bosses welded on. And if we take a look at it in AP Design, we can look at our original version. We can see we've got all the welds in there. So it's an extra process. It's not just the sheet metal part. We've got some assembly just for this one component as well. So we've got our baseline. We can see our cost. We're using a supplier in China, as Chris mentioned, so we can compare like for like. So if we go to CAD, as a design engineer, I'm thinking maybe we can do an injection molded version. So I set to work with a new version. I can make it nice and curvy. I can put lots of new features in, specific for injection molding, some snap hooks, some molded in threads, and some stiffening ribs to make it nice and strong and really protect the underside of the car. Then I can use my best friend as a design engineer. With one click, using the CAD plugin, I can send it up to the aPriori Manufacturing Insights platform and take a look at it inside AP Design. So this is really going to save me a lot of embarrassment by checking the design for any manufacturability issues, so I don't get shouted at too much by the shop floor. And I also get an idea of what our cost engineer is going to think if I've got too many features in there and make it too expensive. So all I've got to do is put in the same parameters to choose the right digital factory, choose the right process. I'm choosing plastic molding. I'm choosing our digital factory in China. And I can change the annual volume to match what we expect for this product. And in a couple of seconds, I'm given a DFM score. So I'm given a medium score, which is not great. We're going to have a few issues, and we've got a cost. So our initial investment in the tooling's quite a bit higher than with our sheet metal version, but the piece part cost is a lot less. So over time, we're going to save a lot of money. But you can see I've got a little bit too carried away with my CAD features. There's lots of DFM issues that we need to sort out. So probably need to dial some of those back before I actually send it to cost engineering or manufacturing. So I go back to CAD. I can make those changes pretty quickly, take out the extra features, come up with a more simplified version, take out the molded in threads and things like that. And then I can just check it again in AP Design. As I said, it's my best friend as a design engineer. I can save myself a lot of shouting at. So I've got my new version. It's slightly cheaper, slightly less material. It's a lot lighter than the sheet metal version as well, and it's a single part, so we haven't got that welding, the secondary operation either. So I've checked it in CAD, checked it in AP Design, but this is where it changes up a little bit. So we've got the part on the platform already, so I can open it in AP Workspace. I've got all the parts in there that I've costed in the past and checked for DFM, and I can find the new design of this scuff plate. And what I can do is tag Cormac and Gibson so that they can start to work in parallel and look at my scenario that I've created and use their expertise to give me some feedback. So really, really quick. It's already on the platform. I just need to tag them and say, guys, can you take a look at this and give me some expert feedback? Over to you, cost engineer.
Thanks, Mark. Hi, today I'm going to be the cost engineer of the team. So I'm going to be using aPriori and AP Workspace. So we're going to begin with aPriori. So I just received an update from our design engineer in AP Workspace. I'm going to jump in from the email notification to see what Mark wants us to look at. So now we have the component open in AP Workspace. We can see he's looking some evaluation from the cost and some feedback. So I'm going to pop into aPriori now on our cloud platform and see where we can save some money. So just opening the part in aPriori, we're going to look at some critical outputs. So the first thing we're going to look at is the machine selection. So we can see here that the machine is a 2,000 kilonewton machine. However, with my experience in our supply base, I know that we have smaller machines that we can utilize. So I'm just going to check what our clamp force is here and understand why we're picking this larger machine. So as we can see here, the clamp force is 410 kilonewtons, which is a lot lower than the 2,000 kilonewtons machine capability. So we're just going to cost it in a 1,000 kilonewton machine and understand why we're not using that machine to start with. So now that we're costing it, we're going to see that we get a cost failure. However, we're going to go and see what the error message is so that we can feed back to Mark if we can make an improvement on the design. And what we can see here is that our mold base size is slightly too large for the machine. So I'm going to take a note to feedback in AP Workspace to ask Mark, can he slightly change his design? The second thing I'm going to do, I'm going to clear my overrides, and I'm going to check the material parameters. So I see that Mark has chosen ABS, but I also know we have a lot of parts in polycarbonate, which is a shorter cycle time and should save us some cost there also. So I'm going to select polycarbonate here to do an initial cost and also feedback to Mark. I also know that some of the properties around polycarbonate will help us save weight. So we're just going to recost with polycarbonate just to show what the difference in cycle time is. As you can see here, the cycle time has reduced by around 50%, so that should give us a good manufacturing saving. And now I'm going to go back into AP Workspace, and I'm going to tag the material and ask Mark, can we change the material? And I'm also going to tag the GCD and ask him, can we reduce the height of the part to allow us to use a smaller machine? So I'm just tagging Mark in both comments to make sure he gets the notifications here. And as you can see, I'm selecting the GCD where I believe we need to change the design. So that's my message back to Mark. I've tagged him in it and assigned him with the notification, and we're ready to go back for a redesign now.
Thanks, Cormac. So after Cormac, our cost engineers, made those comments, I get an email notification, and I can see directly on the model where needs to be changed. So I can very quickly go back into CAD, make some adjustments. The change of material to polycarbonate means I can actually reduce the overall thickness because we've got double the impact strength there. And we can go back to the platform and make Cormac and Gibson aware that I've made those changes. So everybody's fully up to date with the progress.
Thanks, Mark. So as Mark was saying, he's now made the changes to make my life slightly easier, but also Gibson has commented in AP Workspace that potentially the CO2 is slightly too high for this material. So he's also asked us to look at alternate locations or regions to source this part from to understand if we can keep our CO2 down. So I'm initially going to comment back to the team that yes, we'll go back and review some other locations. So we're just tagging the guides in Workspace, and now we're going to jump into AP Pro. So the first thing I'm going to do is update my cost to take in the polycarbonate, just to confirm the lower cycle time for the new design. And while I'm costing this, you'll also notice that the machine size has changed to 1,000 kilonewtons. So the other design change that Mark has made on the GCDs has allowed us to use a smaller machine with lower overhead rates. And as you can see, just to confirm, the polycarbonate is still half the cycle time of the ABS, so another manufacturing saving there. So now we're going to save the scenario and we're going to do some matrix costing. So matrix costing allows us to pick various regions, pick the same volume, but pick different batch sizes to see how our different suppliers' costs would match. So we're going to pick China, Mexico, and the US. And we're going to pick 2 batches per year from China, 4 per year from Mexico, and 12 per year, so 1 per month from the US. So this is going to create a bulk costing screen, which we're then going to cost the 3 locations, and it'll create a pre-created roll-up for us to analyze. So I'm just going to open the roll-up now just to make sure the scenarios have saved correctly. And that means I'm now ready to understand where my choice would be as a cost engineer to reshore. So potentially I would want to reshore to Mexico, but I'm going to feed back to the team in AP Workspace that we need to discuss the sustainability and discuss the overall strategy. So I'm now going to jump back into AP Workspace and tag Mark as design. I'm going to tag Gibson as sustainability, that he is ready to do his piece, and Barton, the sourcing manager. So now I've tagged the 3 of them in the comments. They'll get an email notification, and they'll be ready to go back in and update their pieces.
Thanks, Cormac. So my name's Gibson Peters. I'm going to be the sustainability expert looking at this. We're going to be looking at this within AP Pro and Workspace. So the first thing we want to do, we want to take a look at this scuff plate. We want to understand what the baseline is. So we'll run it through aPriori sustainability, make sure our assumptions are what they need to be for material and location and batch sizes, and we click sustainability. We go in and we can see we have 833 grams of CO2 for this part, and most of the CO2 is driven by the original part by material. We click in, we can see the regions, and we can see China has a high CO2 per kilowatt hour. So we want to look at ways to get out of China to improve our CO2 with the processing. And then I can click in and see what assumptions are made to make that assumption. So electricity factor, and material factor, and energy consumed to make this product. So now I jump back into Workspace and let the team know what I found, tagging the rest of the team, Mark and Cormac, with regards to where we stand with our baseline. So the original part was 833 grams of carbon for the scuff plate, and then anything we can do to get out of China will make an improvement on our CO2. So let the rest of the team know that China's in the best place when it comes to sustainability to make this part. So we tag the folks with that notification in Workspace, and now we can jump in and look at the roll-up that Cormac just created. So we come back in and see the different design iterations over the time, and we can start to compare and see how CO2 is improved or not improved over the different iterations. So we go into our report and export this to Excel. And now we can see we started at 833 grams of CO2 for this part, and now for the final product, we're down at 173, 174 grams of CO2. So I'll chart this really fast to get a sense of what's happening on material process. So we can see we got about 80% reduction, 833 grams, all the way down to 173 grams of CO2. And really see where that change has happened. We changed from metal to plastic. We improved the design a little bit. We switched from ABS to polycarbonate, got another 50%, and then we tweaked and looked at Mexico and United States. So it's a great progress. I'm really happy as a sustainability expert showing not only the CO2 is reduced by 80%, but it looks like the cost has been reduced as well. So I tagged the team and let them know we're making great progress. We've reduced our CO2 by 80% by their design improvements and their hard work. And I think the last thing we can do is really look at how we want to reduce CO2 when it comes to processed CO2. So I'll let Barton take a look at that.
Great, thanks. So I'm Barton Finney. I'm going to be playing the role of the sourcing manager, and I'll be working in AP Workspace. So I see the notification from Gibson saying that he wants to try to move the product out of China due to their carbon energy mix. And so I've been talking with a couple of suppliers in Mexico and the US, and I'm going to go into AP Workspace and give him that feedback. So I'll click the link to do that. Okay, and so the feedback from the supplier in Mexico was that they're using a mix of about 50% renewable energy, but actually our supplier in the US is going to be using 100% renewable energy in the near future. And they're going to be using wind. And so I'm going to give that feedback directly to Gibson so that he can help make a decision on where to source this part from a sustainability perspective. Now, I'm also going to resolve this comment because I want to make it clear to Gibson that I'm not expecting to provide any more feedback for this task that he's assigned to me. So I'm going to go ahead and do that. Now, I'm also going to give feedback to Cormat because in talking to our supplier in the US, our costs are going to be a little bit higher than what he initially estimated. They're going to charge us about 33 cents for the product. And then also, they're going to give us a 3-week lead time. So I want to make sure that he's got that feedback as well as the other people on the team. Okay, great. So I've given my feedback back to the team from the suppliers, and now I'm going to hand it over to Chris to close this out.
Great, thanks Barton and team. All right, so we're just going to do a quick summary of what we just saw here. You know, we saw using the aPriori Manufacturing Insights platform how a team coming together can really get together and use the power of teamwork, right? So we started with version 1. This is where Mark, as our design engineer, started with a sheet metal design. You know, in our DFM score, you can see in the image here, we've got the little green circle. It was okay. Like we didn't have any issues at the moment, but we really needed to reduce the cost of this part. We were at $1.46. You know, we learned from the beginning. We had a new competitor emerging, and we just really needed to generate a product and design a new product that costs as low as we could, right? So we started to go through an initiative here where we went to version 2. And so we now went down from sheet metal, we moved to injection molding, and initially we started with ABS. You know, our young graduate Mark here started off designing it like crazy. He had all these ribs and bosses designed in, and we saw initially that the DFM rating was red. Right? So now, Mark, as a design engineer, used aPriori to look at that, to look at the detail of what were those issues, right? So at this moment, V2, we've got we've got some DFM issues. We have been able to reduce the piece part cost to 55 cents. So we're moving in the right direction there. We're moving in the right direction on weight, down from 124 grams to 28.35. And we've also gone down on carbon footprint. right? So now we're at 410 grams. We still haven't solved the reshoring challenges and lead time challenges of getting down from 12 weeks. But initially, Mark decided, okay, I'm going to focus on a redesign here, right? So I'm going to move from ABS, and start to think about, what could I do? So he started to redesign this product, and you could see the simplification that he did here, moving from V2 to V3. Again, we're moving in the right direction on all the right areas: price, weight, carbon footprint. But now, our lead time still isn't there. At this moment, we've taken it through a couple iterations, right? And Mark now, as a design engineer, has done all this before it's gotten to the expert teams, right? We all have limited time and bandwidth. What if we could get all of the design engineers doing this ahead of the time? Now, there's some challenges with that, as we learned from Tristan earlier on. But if we were able to do that, even a little bit, right? And start to get teams to do this. Now we can relieve some of the teams here, like Cormac in cost engineering, or Gibson, a sustainability expert, to really focus on other areas and use their expertise as they get that. So now, we moved to have Cormac as a cost engineer get involved. We started to look at version 4. And this is where we moved from ABS now to polycarbonate. And we started to see, Cormac asked the question, what if we were able to reduce the length of this part? Because in doing so, we could move it from a 2,000 kilonewton clamp force to 1,000. And in doing so, we're able to reduce the cycle time. And by moving to polycarbonate, now we have higher impact strength and less cooling time. And overall, now I can reduce the thickness even more and overall lower cycle time for this part. So we start to see product costs go in the right direction as well, to 15 cents here. Weight has also gone down, as well as carbon footprint. But he also then looked at version 5, where we use matrix costing to do additional analysis to say, what if I run some scenario analysis if I produce this in the US and also in Mexico? You can see here actually that our price has gone up a bit, but now he's got the power, and the team here has the power to make those trade-off decisions, right? So as my cost perhaps goes up, maybe there's some other areas that are going down in the right direction. And we talked about what does success mean earlier, and I mean that's really up to all the teams here and you and your companies. What's the right decision for you? Now we're enabling you, empowering you with the data to make that decision. And here we've also seen that we've reduced the ability of lead time, right? So now we're down to 2 to 4 weeks, depending on whether US or Mexico. And at this moment, our electricity mix still is not 100% renewable. So we asked Barton to come in as a sourcing manager to take a look at that, right? So he engaged collaboratively with a supplier, and we're able to see, yeah, we are able, to produce this with 100% renewable energy. And now our carbon footprint has gone down, but you'll see here that the price and the lead time did go up a little bit. But overall, from the very beginning, when Mark, as our design engineer, kicked this off, we've making significant progress from version 1. So we use here, you saw an example of the team getting together, of the power of teamwork. We saw a highly collaborative team, helping improve product goals. We also saw that collaborating directly where insights are created helps save time. No more jumping back and forth in between systems, maybe trying to find siloed data and information out there that maybe can be challenging to find. And then third, more sustainable products don't always have to cost more. Sometimes they might. And that's okay, but we need to make the decisions and have the information to make those trade-offs of what's right for you. And then fourth, early design guidance reviews reduces risk. We saw here early on, Mark was able to catch those manufacturability issues and make some changes ahead of time before it got to the other team, and more importantly, before it got to production and manufacturing. So that's our demonstration here to give you a sense of the power of teamwork. Now, we really encourage you to go ahead during coffee break to check out some additional demo sessions. And particularly here, we didn't get the chance to show AP Generate, which now takes the opportunity to automate all of this even faster. So definitely take the opportunity to go and check that out. So thank you all for this. And in a moment, actually right now, we are going to have the exciting part that we mentioned earlier, where we're going to give away this truck here. And actually in the audience, if you look, if everyone actually could stand up, let's stretch a little bit. We'll stand up here and take a look under your seat. There's one lucky winner here who has a golden ticket, who has the ability to win this prize. Any winners? Rick, is Renee here? No winners? Any golden tickets to be found? There's an empty seat, I'm told. So if you're near a seat, you can check that as well. Ah, we have a winner. All right. All right, come on up. All right. Come on up the stage here. All right, and I'm sorry we don't have a mic for you here, but if you wanted to maybe just introduce yourself, who you are, what you're looking to get out of the conference, and how's it been going so far?
Yeah, it's going great. So I'm Rishwan. I work for Rivian Automotive. I've used aPriori for about 5 years now. Like it. Think it can really help, make things better. Yeah.
Great. Well, thanks again, and congratulations. Thanks for joining us here.
Yeah, thank you.
Thank you. All right. This is yours, and don't worry, we're going to ship it home to you. So there's the remote. Thanks again, everyone. We really appreciate it. We do have, we'll take a round of applause, I guess, now, and then we have about 5 minutes. Thank you. We do have a couple minutes left, 5 minutes if I'm told, right, Rick, in where we can have a Q&A. If anyone actually does have questions, we've got a couple of mics of what you just saw. We're happy to take some questions now, if anyone has any. So if you could raise your hand if you have a question, a burning question you'd like to ask, and we'd be happy to address that. Looks like we have one in the front here, if we could.
What was the final decision on the design?
Yeah, so that's a great point. So that's the hardest part, right? Like final decision to make. So we went with version 6. That was where we ended up, right at the end. Where we were able to reduce on costs, design. I mean, it did go up from V5, but overall, for us, it was important to take everything all together, and it really checked all the boxes. Yeah, thank you. We have another one, Peyton in the back.
Yeah.
You want to stand up?
Sure. My name is Uyosa. I'm here from Eaton. My question is, a lot of times in engineering, we're faced with bottlenecks in the processes hand off to people. So I see there we have a platform that supports communication. However, from observation, again, the efficiency drop once we try to hand off work to another group is where we have significant challenges today in engineering. The question is, can we automate the work that the cost engineer did and the work that the sustainability experts did? Or can we embed processes within your platform to allow the design engineer to do their roles?
Great. Yeah, thank you for that question. Barton, do you want to take this initially? And
Yeah. So with AP Workspace, we built the underlying technology to be able to expand it out in the future to help produce things like workflows and things that companies can use it to help automate some of their internal processes. So it's not there yet, but that's the next step that we're looking at currently.
Great. Thanks, Barton. All right. Do we have any other questions?
Yeah.
Okay, we've got one. Oh, I'm sorry. I didn't see here. Maybe we'll take one here and then one over on this side.
Hi, my name is John Kennedy. I'm with Carrier Corporation. The question I have is these threads in AP Workspace, are they based on the part itself, or are they based on the participants, or a thread topic? How do we keep track of the different threads?
Sure. Yeah. Barton, I'm going to have you take this one. Well, we've got our AP Workspace expert here, Barton, so that's why I'm going to Barton here.
Yeah, so the discussions themselves, we built them so that they could be attached to other things in the future, but for right now, they're going to be attached to scenarios. And so you can start a thread around a data field in a scenario, you can start it around GCD in a scenario, but the scenario is kind of like the overall container object of the overall conversations that are happening in the workflow. It's the name of the scenario. So in aPriori, a scenario is the object that is like the document within our system. Yep.
Okay, I think we have maybe time for 2 more. We'll take one over here with Peyton in the back.
So I'm Meenakshi from Modine. We design a product like industrial and automotive products. This is a question to the design engineer. There are structural requirements and durability requirements to be tested when engineers have to design a product. So how is this aPriori tool is connected with the FEA or CFD analysis and a performance point of view as well?
That's a good question. We don't connect directly, but obviously we focus on the DFM. So you can make a lot of decisions around cost and manufacturability before you do any time-consuming FEA. So you can get close to the right cost before you've spent time doing, like time-consuming virtual testing. So it kind of works in parallel to it. But I would say we definitely can get closer to cost targets and weight targets before you go off and do expensive FEA testing.
And we do have just another clarification and ability to integrate using another third-party integration where we can bring those together and you can look at FEA analysis simultaneously while seeing cost impact as you go through that simulation. So just a little clarification there. Okay, we're just up on time. We probably have one more. I did see a hand here in the front, so maybe we'll go here.
Hi all, this is Rushi from Tesla. So my question is for the carbon footprint. So what all different parameters go into, we did see a demonstration in terms of like energy consumption, but what are other parameters which goes into like calculating the CO2 footprint for any given part or assembly?
Sure, great question. So one of the things we focus on is getting a material CO2. So we are layering that onto what we're doing for cost. So we take into account rough mass, regrind, remelt, impact, and then we multiply that by the material factor. So you could see initially with the scuff plate, most of that was material based because there's not a lot of energy going into bending that part. And then when we look at process CO2, we're looking at cycle time, energy used during that cycle time, and then the energy mix carbon factor. So if it's made, all the energy that goes with in China was where we were looking at getting away from that coal-based electricity to clean energy, and that would affect that process CO2 energy.
Does it account for the CO2 footprint for the logistics of the part as well?
That's something we're looking to build into the roadmap for next year. It's on the roadmap.
Okay, we're really up on time, but if you have a follow-up, okay, we'll let it go.
You mentioned EU compliance. Are you dealing with REACH-RoHS, or do you even look at that?
It's on the roadmap to look at RoHS. What's that?
Oh,
Mike.
Go ahead, yeah.
I'll try and speak up. Oh, there, my mic came back on. That's something we're looking at building into the platform.
The question was around REACH and RoHS compliance, and what are we doing to comply with that?
Yeah. So we're going to look at building that into the future. So identifying, especially when we look at PCBAs and other things that impact that part of sustainability. Primarily been focused on the material and electricity, but building out those additional features are on the roadmap for next year.
All right. Thank you so much, everyone. And how about a round of applause for the team here, panelists. Thank you so much.
aPriori, making profitability and sustainability a reality for a better world.